Live.
All right, what's up? What's up, people? 12.5758.
We got some eights.
It's the relay that I've been on about, the 180-degree magnets and then the 90-degree electromagnets. And I incorporated my cat banks into the mix, and it's been working pretty good. I started it at 345. I'm Papa Bale, by the way.
Welcome.
Papa Bale.
So you started at 3.5.
No, 345. So it is now
Oh, like six.
seven,
Yeah.
7 or 6.
Time. I got you.
What time is it?
Welcome in, Tech. Thanks
Hey,
for
what's
dropping
up?
by.
Got the relay going. Um, one battery is a little bit stronger than the other one, and I think it's due to the different size coils. But it's pretty equal. It's burning down rather slowly. So I mean, the high frequency is helping out a lot. Yeah, this is gonna be at like 12:58 for a good, 5 to 7 minutes, maybe longer. And so what we have here is the trifilar strand is charging the cap banks, and then the cap banks are charging the batteries, and the batteries are running the drive. So there's a little bit less going. Trifilar strands generate less than the input automatically because there's loss in how the energy is transferred. In the transformer style, there's the energy loss there. It's it's not much, but it's like enough to cause a loss in the whole system.
Tech says he's looking forward to collaborating with us in the near future.
Sounds cool, man.
How's it going, SAQ?
Hey,
Welcome in. Glad you found us again.
all right. I just think this is awesome, and I really feel like having the cap bank for like any energy that could be stored. There is energy being stored in these caps right here. That is, well, I think there's actually some backlash from the batteries as well because you connect to the positive and the negative terminal. There's a wire here that connects into the positive and negative terminal of the cap bank right here. And these lights are on this side of the bridge rectifiers and the DC caps. So those lights are going to light up just from being connected to the batteries on the DC side.
So,
But
how much is the input and the output with this one?
12 volts. The output, I can't really say. I know that these are 12-volt batteries. I do believe that it's just under 12 volts for the output, so like 11.5, maybe 10.5. We got a zoo out there, man. That's awesome. Okay, so it's down to 12.57. So if you like can do the snap math in your head, and it's like it took that long to go from 12.58 to 12.57, that means that it'd be right around 10.5 11 volts
Yeah.
for the output. Maybe a little more. Maybe 11.5.
And then what is this number? The 1257.
That is this battery's current value, uh, voltage value.
Okay, so that's how
And
much
then
left
that
in the
meter
battery.
over there is this battery's value.
Okay. And this says 12.5.
Yeah.
So we're not plugged into the power supply. Power supply's off. This is all batteries.
Yeah, so I mean, at a rate of like 10 minutes per 100, uh, you got usable battery. It's gonna probably sometime tonight, it'll stop being optimal, and it'll start functioning less efficient.
Do we have anything measuring current amperage?
Just the meters. I don't have any TikTok or any what are they called? Melanome?
I don't even know.
The ampermeter, the analog ampermeter. I don't have one of those.
Okay.
I don't have one of those clamps that go around the wire. I don't have one of those. But I would say that at its current rate, it's right around 350 to 400 milliamps. But the generation, I couldn't tell you on the flip side how many amps are being generated. I would have to say that at least half of what's being spent is being generated. Because it's transformer, it's trifilar, so you get the benefit of the drive through proximity. Just not all the benefit. So I mean, like, and I don't even have a primary output set up yet. This is just the trifilar strands. So
Is this a flywheel setup?
this I would not consider a flywheel setup. It does have flywheel. I know it's very light. Um, it's all motor driven.
Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like. Let's see if we can get the likes up to 20 tonight. Let's do this. Thank y'all. Appreciate the like.
Now this one has flywheel applications. There are 9 magnets here, about 1.5 pounds of magnets on the outside. There's a 1 pound toroid magnet for levitation, and this weighs about 2 pounds. It's 100% PLA print. It took literally almost a whole spool to print this thing.
Mm-hmm.
It is very flywheel.
Hey Jace, welcome in. Thanks for dropping by. Let's see if we can make some noise and bring a lot of people up in here tonight.
Let's see.
This is Papa Bale. We're working with Pulse Motors. Let us know if you have any questions.
Still at 12.57. Is that one still at 12.5?
Yes.
Wow. Wow, people. That is awesome. That one started at 12.5 when I turned it on. So it's bound to change soon, but it's been like that for a while. And you know, this coil, I put it pole to pole, and it actually started going up. The value in battery voltage started to go up, but only for a little bit, because then the rotor slowed down, and And of course, when it slowed down, it stopped generating as much as it was altogether, and that was a downward trajectory. So I removed the coil. I'm thinking about hooking it back up and leaving it in a 0 point formation, so like up against the rotor this way instead of pole to pole. And we're going to see if we can't generate enough. And then we're just gonna clip it to the cap bank. Now I always thought that, you know, there's already 2 wires connected to the cap bank, and that's the trifilers. So I thought that the big coil over there would short out the trifiler through the connection, but the pathway to the battery is shorter by a long shot. So that's not what happens, which is good. So the path of least resistance is still going through the cap banks and to the battery instead of going and shorting out the coil. So that's a good thing. That's awesome. And I just think that having it that close without having the direct magnet attraction of the pole is going to reduce 2 things. It's going to reduce the effect that the core has on the rotor, and it's going to reduce the effect of the lens effect.
Hey everybody, thanks for dropping in. I see we got 26 watching. Let's get the likes up to 10. Thank you so much for the likes.
All right.
Drop a subscribe. Let us know if you have any questions.
There's one way to find out for sure, but you know, I need to make another coil. Right now I only have one of these bad boys. And then you hook this coil up to the one that this is charging, the one that this trifiber is hooked up to. And that way these 2 will charge at the same time. And it doesn't look like it really matters because there's a lot of energy going through there.
Are the batteries on parallel or serial?
These are parallel. So we got 1 battery for this coil, and we got 1 battery for this coil. These are not hooked up, these little ones.
Thanks for dropping in, everybody. I see we got 39 people watching.
Awesome.
Let's get the likes up to 10. We appreciate y'all. Thanks for the likes.
Well, we've reached like an equilibrium. I think we're still dropping, but very slowly. We're still at 12.57.
12.5 over here.
Still at 12.5 over there. Apparently this battery is dropping a little bit faster than the other battery, which would mean that the one that's charging this battery is charging a little bit less than the one that's charging this battery, which would make sense because the coils are different. It's going to change soon again.
Thank you for the like.
Thank you.
Yep, the more likes we get, the more people will drop in, the more questions. And we love the questions.
Yeah, if I can answer it, I will. If not, I'll just say I don't know. But the way this relay works is that there's 2 magnets on the rotor at 180 degrees. Okay, so when it lines up 180 right here, it's gonna hit this coil will be off. And then when it lines up right here, this coil will be on, this coil will be off. And that's what allows it to work without any relays or, you know, this is just solid connections, basically. I mean, there is a cap bank incorporated. I incorporated the cap bank because I had two of them. And apparently, you know, it's working very well. Exactly what's happening in the cap bank, I could describe it. It comes in as AC, and then there's 4 AC caps, one for each row. It goes through the AC cap into the bridge rectifiers. There's 4 bridge rectifiers, one for each row. And then there's 5 caps on the other side, DC caps, for after it's been rectified. In series, okay, but there's 20 altogether. So each row has got 5 caps. And then they're hooked in parallel. So they're hooked all together like this. But it's neat. It's neat. It's like smart. So like if you unplug one thing or plug something in the middle, it's got this little middle port too. To like be in series with stuff instead of like parallel the way it is now.
Hey everybody, thanks for dropping in. See, we got 43 watching. We appreciate y'all so much. Drop us a like, subscribe, let us know if you have any comments.
Yeah. So this is so cool right now, man. I'm so happy. It's still at 12.57. Hasn't dropped at all since it dropped from 5.8.
Yeah, that's pretty good. That it's still draining, but very, very, very slowly.
All right. This is going to be like the only really big change that I make tonight. I'm going to hook up this coil to, I believe it's going to be this one. Oh, it's going down.
Hey everybody, thanks for dropping in. See, we're showing 41 watching right now. Let's see if we can get that doubled. Let's see if we can get it up to 80. Let's make some noise. Let's drop some likes. Let us know if you have any comments. If you guys want to see anything done here with the pulse motor. Let's see if we can get 100 people up in on this stream.
Let's do it.
Let's do it, folks. It's up to you guys watching. Hit that like button.
All right.
Bring them in.
Wow, did you hear that snap, crackle, pop right there?
A little bit. Yeah, it was a little bit.
No, I don't know. it's been at 12. Is it 12.5 still over there?
It's off.
Oh, it's off.
All right, we got 42 watching. Let's get it up to 50. Yeah.
All right. Let me turn that back on because the coil is active. The extra juice.
Got it up to 50. Let's get it up to 60. Let's do it.
Let's do it. Uh-oh.
It's coming down.
Yeah, but I mean, it hasn't been on very long.
Yeah, 20 minutes. Hey, everybody, welcome in. Thanks for dropping by. Drop us a like if you like this kind of content. We're working with pulse motors today. Let us know if you have any questions.
So I'm thinking maybe I should go pole to pole just to see if we can give it a little jump start. So what that means, it's going like that.
And we are working with pulse motors from a stored input today, right now. 212 volts.
So what we're doing now, we put the coil pole to pole, and we're seeing if we can't generate enough from this coil and this tri-filer going through that cap bank to bring this battery up to 12.5. I don't think so. We'll see though.
All right, we got 54
It did
people
it. Oh my God,
watching.
it's doing it.
Thank you guys so much.
Oh, come
it was
on.
up. It was up there.
Yeah.
It was there.
It was there, man. It'll go there again, I hope. Oh man.
Success. We got some likes for that. Thank you for the likes, folks. Appreciate it.
Yeah. That's so cool. Thank you. Now, will it stay going on an upward trend? I think I'll have to back it out like a centimeter for that to happen. But we're going to leave it where it is right now.
Welcome in, everybody. Thank you for joining the channel. This is Papa Bale. We're working with pulse motors tonight. Drop us a like and subscribe. Let us know if you have any questions. All right, we got 60 people watching. Welcome in. We're looking to get it up above 100. Drop some likes. Hit those reactions. Hit those hearts and 100s.
So we just picked up a little bit of speed. We lost a little bit of generation, of course, but we backed it out a little bit. But I think we're going to gain by the speed. And then see what I'm banking on is that the field expands a little bit and we get more generation from the speed than we did from it being close. That's what I'm hoping.
And then there's the supply. We are not using the power supply. It's all from the batteries. Charging and using.
Oh, it went up, dude. And it hasn't gone up yet, but I mean, it went from 1249 to 1250.
Yes.
And then what it goes from there is going to tell the tale. Because if that one goes up, the general speed of the whole thing is going to go up, and that means that this one might go up too.
Right.
Because this one's still at 12.57.
Hey everybody, thanks for joining in. I see we got 9 likes. Let's get it up to 15. Appreciate y'all. Thank you so much. Let us know if you have any questions.
But you know, these cap banks, I can't say enough about them, and they're not really cap banks. What they are is like filter, scrubber, AC to DC cap banks. But it's really an input-output kind of thing, and you don't get to choose really when that happens. I mean, you do to a certain extent, but I mean, there's a constant flow of energy going through these things.
Right.
It's not like a cap bank where you charge it up and then you move it somewhere else. As soon as I disconnect this, it's gonna drain. And like as soon as like I turn this off, it'll drain. Just like a cap bank, but a cap bank will take a lot longer to drain. So, I mean, I don't know if that has anything to do with it, but I know that the in and the out is constant.
Hey everybody, thanks for dropping in. Hit the like button, drop us a subscribe if you like this kind of content. We're doing lives and we got a large video library. And this is all DIY self-learning. So let us know if you have any questions or comments.
I'm enthralled. I think this is great. Especially if this goes up to 5.1. I mean, it's to the races from that point.
We're outside.
There you go.
Such a wonderful day out.
Yes, it is.
I spent some time at the pool. I walked around the pond like 5 times.
Now, what did y'all do today?
Yeah.
You guys have some good times?
Awesome. I love these little coils though. Soft iron core, 2 layers of 20 gauge. They hit, man, they hit really hard. I put them underneath the green paper and it was like the paper turned white. It was so strong, the feel.
Hey everybody, welcome in. I show we got 58 watching. Let's see if we can get it up to 100.
Let's see.
Like, subscribe, share, comment. Hit the reaction buttons. We'll make some noise.
Heck yeah. This is pretty much it though. I mean, I'm going to reiterate, I'm going to talk, I should go through the whole setup again real quick. They're both trifilar coils. And this is a pickup coil of 32 gauge. It's 13,000 turns of 32 gauge. And it's working in conjunction with the trifilar strand of this coil. So both the trifilar strand and this coil are hooked to this cap bank. And then this cap bank is both hooked to this meter over here and that battery right there. And this is 12.5 right now.
12. That went from 12.56 to 12.57.
And that one went up.
Yeah, and it's teetering.
It's fluctuating.
Yeah.
It's going to go down. That's okay. When they level out, I think is when we're going to see our biggest stretch. Whoa.
Nice.
Whoa.
Good job.
Okay. Nice.
Nice catch. Welcome in, everybody. Thanks for dropping in. Like, subscribe. Let us know if you have any comments. Let's see if we can get 100 people watching.
Yeah, I started this at 3:45 this afternoon, and it's got to be around 8 o'clock now.
7:30.
7:30. So almost 4 hours. It's gone down, I'd say maybe a tenth since I started it.
So from 12.6 to 12.5.
Yeah.
Hey everybody, welcome in. 66 people watching. This is Papa Bale.
Hey,
I'm Christopher. Thanks for dropping in.
maybe it was 12.6 on this one.
That one turned off too.
Okay, I got it. Yeah, 5.6. But I'm expecting this one to go down a lot faster than that one went down, and that one might be going up. Because it's higher. Because it's higher and it's a relay based on symmetry. The coils are different. So it's going to be lopsided, and I just want to take the readings anyway because I know the dimensions and the differences in the coils. Therefore, I can do whatever math is necessary. Yeah.
All right, we got a comment from Uzi. Probably both. The battery 8 in parallel one way, and then those groups are in series with each other.
You're talking about the cap banks here?
I think so.
Yeah. It's basically split into two sides, an AC1 and an AC2. And then those sides are hooked together. So, but what makes that possible is the bridge rectifiers in the middle.
Oh, and he was answering for the
Oh,
for the actual comments too. Appreciate it, Uzi.
thank you. Thank you.
We got 75 people watching. What's going on, y'all? Welcome in.
Hey, what's up?
Drop us a like. Let us know if you have any comments about the build. We're working with pulse motors this evening. Electromagnetism. Experiments.
So I'm hoping that one will make it up to 12.51. I'm not hopeful. I think it's gonna slow down. It doesn't sound like it's slowed down at all. I'm not gonna go either way. I'm on the fence. There's no fence, but I'm on the fence.
Oh, should we tell them?
It's 4.9.
Yeah.
Oh, that's what I thought was gonna happen.
Oh.
No, it's all right. It's all right, man. I was ahead of the game there.
Drop a like and subscribe.
All right, dang.
No, that's good. That's honesty. That's integrity. That's good.
So I mean, that coil's not really doing. I mean, it did it for a second, but it's not really doing it.
For a second.
Yeah. But honestly, you can't get by that something is happening when it's like for 100th of a volt, it takes 10 minutes to deplete on the battery. And there's definitely some charging going on there. Just not as much as what's being spent. And they are 20 amp hour batteries, but still, man, there's definitely some charging going on. Considering this is a 1mm drive, and this coil right here, it alone at 12 volts, well, with the 2-magnet rotor, I'm thinking about 800 milliamps for this coil to run.
Hey everybody, welcome in. I see we got 50 people watching. We got 10 likes. Thank you guys so much. Appreciate it. Let's see if we can get it up to 20.
Because with the 2-magnet rotor, I could crank it all the way up on the power supply to 12 volts, and it would be 0.8, 0.9. So that's 800, 900 milliamps going in. As for what's coming out, I can only speculate right now. I don't have any of those TikTok meters. Yeah. Metronome meters. You know, like the amp meters that are analog. I don't have any of the clamp meters. All I have is the meters that you see.
Thank you for the likes.
I'll look up the amps real quick on this one. but it's not, there's no load. Or the battery is the load, actually. So there is a load.
Let's see if we can get the likes up to 20. Thank you guys so much. We appreciate y'all.
So 243 milliamps. Nice. That actually feels right. You know, that feels accurate.
Thank you for the like.
Yeah, thanks. All right, hey, yeah, this is good. I think this reading is good. I've had some argument about the meter not reading it right, but I feel like that's good, considering what I know about it. And we're only getting the DC reading because it's coming off the cat bank. Now let me see. We'll go and it's going to be a straight line, but we'll zoom in on it. And it should be above the mark by a little bit, like 12 volts. See? It's above the median line by about 12. Perfect.
Perfect.
Oh, wow. It said 5-1 for a second. It was just adjusting.
Everybody, thanks for dropping in. This is Papa Bale. Welcome to the channel. We're working with pulse motors this evening.
I wonder if I
Drop
did
us a like,
this.
subscribe. Let us know if you have any questions.
I backed it off a little bit because I think the lens effect is kind of dragging the motor down. So I figured if I backed it out a little bit, drive coil. See, now there's about an inch there.
Let's see if we can get it up to 100 people coming up into this live stream. We appreciate you guys so much. Thanks for the likes. Let us know if you have any questions.
Thank you. I wonder if I back this one off as well. So you want to get it in the magnetic field, and it's easier with a core to back it off and still get the maximum benefit. Because you get that interaction with the core and that sends it through the whole coil. And I think it is spinning a little bit faster since I backed it off. So about 940?
935.
935.
Got 50 people watching. Let's see if we can get it up to 100. Thank you guys for dropping in. Like and subscribe if you like this kind of content.
Heck yeah.
Let us know if you have any questions.
I'm going to say it again. It's been a beautiful day. I got a nice amount of sun. So these two coils are working in conjunction with this cap bank to charge that battery, and we're at 12.49.
12.56 over here.
And I mean, throughout this whole live stream, we'll probably lose 300ths altogether.
That's not a whole lot.
No.
That's a little
We'll
bit.
lose we'll lose 3 off of that, and we'll lose 2 off of this. So 5 altogether.
All right.
That's what I think, based on, the hour or so for the update, and just how I did the math in my head. That's what I think will happen.
Hey, everybody, thanks for dropping in. I see we got 13 likes. Let's see if we can get that up to 20. We appreciate y'all so much. Thank you, thank you.
Hello, hello. So, I gotta reiterate how awesome these cap banks are. It takes the AC from the trifilar strand and turns it into scrubbed DC. It's like really good DC coming out the cap bank there, and that goes straight into the battery. Now, I would assume that the amount going through the AC side and coming out the DC side is more than the backlash from the battery. I assume that there is energy going in to the batteries, and then this is not the standard rate of, that the battery goes down. It'll go down quicker if I deactivate these cap banks. It'll go down really fast.
Right.
20 amp hours or not, it's going to go down fast. That's what alternators are all about in cars. It's the only reason the battery lasts so long is because it's being charged all the time.
Right.
And you could say that it's kind of like that. I mean, an alternator probably functions better than this does, but it's kind of the same idea, except that, well, I mean, an alternator does charge the battery when the car is running, so it is kind of like an alternator. It has to be running for it to function. What I'm getting at is not every wheel that spins is going to function like this. Not every relay is going to be like this. I mean, if you try and put this coil up here, you're probably going to get some smoke somewhere. I mean, literally, it's based on position. This whole thing is based on position. And I think that the cap banks are definitely changing the game. They're a new addition to the relay. As far as I can tell, 4.8, 12.48. I think we're starting to drop faster now. I'm not sure. That was a little quick.
Using the battery. Hey, everybody, thanks for dropping in. I see we got 14 likes. Let's see if we can get that up to 20. Appreciate y'all. Thank you for the likes.
I wonder. Oh, it's back up to 4.9. Oh, it's on the it's breaking.
Teetering. All right.
Teetering. So, with that, I think that was a little fast for when I backed them off. I think I'm going to put them back up closer again.
Hey, everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe if you like this kind of content. We're working with electromagnetism experiments and pulse motors today.
We've been here before, and it was at 12.5.
Yeah.
So I don't know. Well, that just turned on. Yeah, but I think we can control, at least for a little bit, whether or not it's going to go up or down 12.55. And see, I need another one of these coils because then it would be even Steven. Oh, that's so cool. Is it still lined up? I can hardly tell. Not really.
Looks alright.
All right. Yeah, I think that. See, the problem with the 32 gauge coil and generating the electricity the way I am with that is that a lot of it is frothy. If you think about it being beer, a lot of it is head. No good. But, you know, with every glass of beer, you get beer in your cup.
Hey everybody, welcome to the channel. Thanks for dropping in.
And if it's not beer, it's Pepsi. You know, it's something with fizz. And the fizz is, there's a lot of fizz in that coil. But there is some usable energy as well. And putting it through the cap bank really helps sort that out. But I think, wow, can we put it up even closer? I wonder.
Hey everybody, thanks for dropping in. Let's see if we can get the likes up to 20. Appreciate y'all. Thanks for the likes.
Thank you. All right, heck yeah. What's up? What's up, guys? Pretty good. And I can move that one up closer because the cores don't go all the way through the front. Man, I wonder. That's actually functioning very well. All right, sweet. Does this sound like it's slowing down or what?
I don't know.
Yeah, I'm kind of out of it too.
Hey everybody, welcome to the channel. Thanks for dropping in. Let us know if you have any comments or questions.
We're trying to get this battery up to 12.5. It's at 12.49, and it's in a relay. And typically, they're supposed to go down. The battery values are supposed to go down. But if we can get them to go up, then maybe we can get them to go up when we want them to. And, you know, I mean, just a whole lot of practical applications can be explored.
Hey Cody, welcome in. Thanks for dropping in. We're working with pulse motors this evening. Let us know if you have any questions.
Hey,
Here's the whole setup right here. And these are the measurements on the batteries here. 12-volt batteries. Uses magnets to generate electricity, electromagnetism.
oh, yeah, I think it's going to go up.
And then a rotor. And then coils. So rotor, coils, and the magnets go in the rotor.
I keep on hearing a frequency change, and it sounds like it's slowing down, but then it levels off. But I mean, those coils are kind of right up on the wheel right now. I mean, this one isn't, because this one was going to latch right onto the wheel if I get it too close.
Is it a DC motor?
Yes.
Yes, it is.
Brushless DC. Tri-fiber coils. We're currently using the tri-fiber strand to charge the batteries. Through the cap banks, of course. And that's where this coil comes into play. This is a 22 gauge tri-fiber strand hooked to that cap bank, and this is a 13,000 32 gauge coil hooked to the same cap bank. And it's charging this battery right here, which is the left battery, my left.
Yep, your left.
Yeah. I think I'm going to let this run until it wants to stop. Or I could stop it, make another one of these coils, and then start it up again when I have all the pieces. And it's doing really good for not having all the pieces.
Yeah. That's for sure. Hey everybody, thanks for dropping in. Leave us a like, subscribe, let us know if you have any comments.
I got another idea for coils. Like this size right here. 24, 32, about, if I remember correctly, 700 turns of those two gauges. Maybe a little less. I know that it was 350, well, no, about 700 turns. Yeah, use these coils for that. I don't know, I think these would work out like pretty good actually. I know they're tiny, but that's not really the way the power flows in this system. What it is you get leftover power. The motor runs, and then you get a dump off of energy that you don't use from the power supply. So it's like the Bedini dump, like go straight from the collector onto the next transistor. But it's minus whatever you use to run this. And then, I mean, there is a way that you can make the length and the gauge of the coil work to your benefit when you're putting the electricity through it. So, like if your resistance, if your ohms is right, and the amount of current you can put through the wire is right, then you get the perfect. That's what resistance is. It's like the current pushes, and when it gets to the resistance amount, it goes through with the force of, you know, what it takes to get past that resistance. So it's like, if you do it right, you can get an umpteen amount of power out of resistance. You can get a lot of power. But I mean, if you do it wrong, you're gonna be stalled out. You know, there's lots of things. Too many ohms, and you're gonna stall out. But I've been like experimenting with using coils as resistors. So virtually what I do is I put this on my meter, I put it to ohms. This one right here is 168 ohms. So this coil is a 168 ohm resistor. It's 1500 turns, 32. So, like that's 168. There's different. See, this one right here is 1500 turns as well. So that's another 170 ohms. But you can see it's a totally different format, you know? Because it's really about the gauge and the length of the wire when you're doing ohms.
All right, so Cody asks, so 2 coils are for power generation, question mark, and the one in the center is your motor pulse.
All right. So I'll explain these 2 coils are drive coils. There's a 20 gauge strand in this one for a drive, and there's an 18 gauge in this one for a drive. And then this one has a 30 gauge trigger for the transistor, which is over here. And this one has a 32 gauge trigger for the transistor, which is over there. And then there's the trifilar strand, which is a 22 gauge on this coil. And then the trifilar strand is a 20 gauge on this coil. And then this coil is solely there to generate AC electricity, and it works in tandem with this trifilar strand. So this trifilar strand and this coil are hooked up to this cap bank, so that charging doesn't interfere with everything. Has to be timed at 180 degrees or 90 degrees, and that's what I did. So when they're at 180 degrees here, they're both hitting at the same time.
What's up, Zinc? How's it going? Welcome in.
Hey, because I was told, you know, and I've experienced on my own, you're not supposed to charge and spend with the battery at the same time. Exactly. So we found a way to do that without without using a relay, so we don't have to use any of this stuff. And yeah, having this booster coil was a big question mark for me, but it's working out just fine. And of course, now we're up in the middle of 12.49, and yeah, I don't know if we're going to be on when we reach 1250. If we reach 1250. Right now, it feels like it's going up, but I don't know. We'll see. I think this is awesome. Let's see if it's still going fast.
Do you know
It did slow down.
Do you know how to test if it produces more than it's using?
There's a specific way. I don't know any way to do it. No. I know that we're generating about 243 milliamps of amperage in this cat bank.
Oh, I see what he's saying. Pull the battery from the loop and see if it powers itself. That's what I figured you were going to do. Do you want to explain why you're looking like that?
Yeah, well, there's no loop.
There we go.
There's no loop here. This is, it is, it's a relay. It's not a loop. And I was just struggling to see if there was any way that I could do a loop. And then, not the way it's wired at all. I have to rewire it completely. So you got to understand that the 180-degree there's only two magnets in this rotor. The 180-degree magnets allows me to have both of the batteries hooked up, and then it's really hard for me to explain it, I guess. It's safe. Let me just put it that way.
Hey everybody, thanks for dropping in. Let's see if we can get 100 people watching the channel. Hit the like, subscribe, let us know if you have any comments.
Because the cat banks are hooked directly to the batteries, and the batteries are hooked directly to the drive. So I can see where there's a kind of a loop, but it's
He said you would have to bring the charge wires for the battery into the wires from the battery to power the motor, and then disconnect the battery.
oh, I get what you're saying. And because of the fact that these are trifilers, I already know that's not going to work.
Trifilar coils.
The trifilers don't generate any power unless there's power.
And there's no power.
No, there's battery power.
There's battery power. I'm losing it. Oh. All right, we got 50 people watching. Let's see if we can get it to 100.
All right.
Thanks for dropping in.
I can really feel like the energy coursing through this coil, man. It's amazing.
And I think we need you guys for the help. Hit the like button, hit the reactions. Let us know if you have any question. All right, so yeah, I don't remember where he said this, but he's like, that's the disconnect. So you guys were on the same page right then. Right now we're using this to test, so just for experimentation and taking data. Thank you for the likes. Let's see if we can get the likes up to 20. Appreciate y'all.
Oh, 12.49 still. Not bad.
And here is some of that data.
Oh, I think it just went down to 4.8 though. Yep.
Yep, it's going down. And we're going down. Okay.
I think it went down. Every time I switch it over to the amps, it goes down.
This one kicked off, but I'm assuming it's at 12.56 or 12.5. No, it was at 12.53, so 12.52.
Alright, I'm gonna back everything off.
In the future, well, this is a do-it-yourself at-home hobby with pulse motors and electromagnetism. So more safe experimentation, more self-learning, more data. As you know, this is all bootstrapped, so we don't have all the top equipment, and we're still getting a lot of good stuff. So we appreciate y'all, and check out the channel because
Check it out.
see the learning journey there. See how far we've come, and then you can tell us what to make next.
But the amps are pretty steady at 2.43. 2.43. It's determining whether or not it wants to go up. I think what happens is that the meter gets comfortable at a certain number, and then it's got to dip like way down into the next variable for it to actually change. And it's you gotta move it around a little bit to get your accurate reading, which is probably what it is right now.
Hey everybody, thanks for dropping it in. We appreciate y'all watching. Hit the like button, subscribe, let us know if you have any questions. Let's see if we can get more and more people dropping in on this stream. So just like and share, and appreciate y'all.
Heck yeah. So reality, this has been very good so far. I mean, altogether probably a tenth or 12 tenths, 12 100ths.
Yeah, in total.
Yeah, 12 100ths on both batteries.
Yeah.
So I think that's pretty cool.
55 people watching. What's up? Bring it. Let's go to 100. Let's do this.
Love you guys. Love you. All right. I think it's really, honestly, when you think about it, there's no way that you can be generating the same amount that you're spending with a trifilar setup. Because if you measure a trifilar setup when it's just running a coil, you hook your meter up to the trifilar, it's always going to read, at least 3 volts less. So automatically you're already doing 3 volts less.
You're already swinging at a handicap.
Yeah.
Yeah.
Right.
Mm-hmm.
But so you're automatically already gonna it's not over unity automatically. But this cap bank, I don't know, it may smooth everything out a little bit, makes everything go a little bit farther. I think it's a real simple situation here. and I don't have to add additional clips to add an output. The output, this is what's cool. When it's a trifilar strand, most of the output, if there's not an output, is forced through that strand. Okay? So like if you don't have your typical output, Bendini output, the trifilar strand will absorb most of that energy. Because there's an output for it, there's a release for it. It's going somewhere, so that's where it's going to go. It's not going here because there's nowhere for it to go. So it's just, it's null. It's not even, no be there. That's what it is. It's no be there.
It's no be there.
No be there. So I would say most of the trifilar, most of the juice that's being passed on from the system is being passed through the trifilar because there's no output for the transistor. So what I'm saying is, it's not over unity. It's definitely not over unity. It's close to unity.
Drop a like.
That's the reality. It's close to unity.
Honesty, my man. He's not a free energy snake oil salesman. This is good. Drop a like.
It's not that I don't, well, I mean, me personally, it's not that I don't listen to people that have opinions supporting free energy. I listen to them all the time. Mainly what I say is show me the scat. I mean, we can talk theory all night, but I mean, at the end, it's like show me the money.
Yeah, the droppings, the quan.
Show me the back guano.
Thanks for dropping in, everybody. Let's see if we can get the likes up to 20. Appreciate y'all.
And it's cool, and I appreciate the conversation. I love talking about stuff. But in the end of the day, I don't believe in much. It's not about faith or belief for me. It's about show me the scat. It's about proof. It's about reality. You know, and what, you know, just playing by the rules. And I'm pretty sure we can get to where we want to go by playing by the rules. We just don't know the rules yet. We don't understand the rules that we already know. And I mean, apples get mixed with oranges every single day, and it's okay. Literally, it's okay, but it's wrong.
That's right, because you bite into the apple and then orange juice comes out. So you're like, man, this dude sold me orange apples.
And it's like, oh man, physics is awesome.
Mm-hmm.
You know, physics is intertwined with this reality. So, I mean, I would learn it good. You don't have to know it word for word. I mean, the textbook definitions are great, but you got to understand what they mean. And we don't really know that necessarily right now. We don't know what they all mean. And we try to mix apples with oranges when it comes to physics. Okay, we do all the time. It's like we mix this law with that law when this law doesn't apply to this law at all. It doesn't. It's apples and oranges.
It's a papaya, man.
But I've seen the scat of, you know, equal and opposite reaction. So 180 degrees, right? A magnet flew out of one of my rotors, went that way. My rotor and the shaft and everything else went that way.
Ooh, we got some stuff.
At 2,700 RPMs, man. I think I have the shaft laying over here. The shaft was literally bent like this, and the rotor was literally on the other side of the room, but the equal and opposite reaction played itself out perfectly. 180 degrees. The magnet, little ass magnet like this, flies this way. 180, everything else goes the other way.
Whoa!
I was like, yeah, man. But anyway, since then, my rotor designs have become a lot better. And that was my birthday. That was my birthday stream, man. And I swear to God, I had axial flux going 2,700 RPMs. And then all of a sudden, the magnet broke right through the plastic. Because it had a little bit of wiggle room in there, so I could easily remove them. I didn't think it would rip right through the plastic. It just totally destroyed it. Just that little tiny bit of wiggle room at speeds like that is enough to totally devastate everything.
Devastation across the nation.
So I mean, like, if you're planning on having your stuff be modular, your magnets need to be stable. They like right here, it sounds like they're wiggling, but that's the bearing. I've got what do you call it? Fabric softener stuffed in the magnet holes so that they are snug in their housing. So there's no wiggle room. You know, it's like, it's important. Haven't gotten any rotors to go that fast since then, though. The axial flux are truly amazing.
Appreciate it. Get it. Thanks for the comment.
Heck yeah.
He get it, believes in you.
Thank you. I think this is great.
Five minutes. We can do 5 minutes.
All right, yeah. Yeah, I can do 5 minutes. Thanks for hanging out, everybody. I really appreciate you hanging out. We kept it really simple tonight. We moved the coil around a little bit to try and get some more voltage. We failed. It's all right. I think we're getting a little bit more voltage regardless of whether or not the meter's going up. Anyway, so but yeah, the relay is on, and I will keep you posted as to how long, you know, it lasts for. Mathematically, I think it's going to be about a day and a half from now when I decide to I don't know. I've heard that like 11.5 for the batteries is a good place to shut down, because then you're not getting as much either way. So cool, man. So cool. I'm glad that it's actually working with the cap banks. I know that they changed the dynamics a little bit of the whole thing, but I think it's okay. It's okay so far. There's no smoke. We're getting pretty good, you know, accurate assessment on how long it's going to last for. And that's pretty much what it's all about. It's about how the energy gets swapped back and forth. And I'm pretty sure if I get another one of these coils, that, you know, we'll be better off. I had a really nice blue one, but I put a core in it and I got it too close to the wheel, and the wheel threw the coil and the bobbin broke into a million pieces and the wire went everywhere.
Bada boom.
Bada boom, and that was the death of the blue coil. That was 11,000 turns of 32 gauge down the drain. Couldn't save it. I looked at it, I picked it up, and it was totally, to see if I could like patch it up, you know, because it's a lot of wire that just got wasted. And the answer was no. That's all right. It's all right.
Learnings.
Yeah, I get that answer a lot, but you know, I get a lot of yeses too. So yeah, I think at 100, I think it's about 20 minutes. Let me think here. What am I trying to say? The one that's charging that battery, so this one, is generating a lot more than that one. So I think this 20 gauge strand is not generating as much as this 22 gauge strand by a long shot. So that gives me a good scope as to what the next barrage of coils should be. I think that the 20 gauge drive is good. I think a 22 gauge trifiler is good, and I think anywhere between 750 and 1,000 turns is good. And that's good. That's really all I got for right now. I appreciate everybody swinging through. And please like, subscribe, join up. Peace out.